Hey, welcome back. We're going to get some answers to these parallel circuits practice puzzles here. So we're going to look into this purple one first, practice puzzle number 2. If you missed the video giving practice puzzle number 1, take a look at that because I'm going to fly through these, and I took some more time explaining things in the first one. And then we're going to look at this practice puzzle number 3. So let's go. Let's get into it. We're going to have 3 resistors of 4, 6, and 12 ohms respectively, wired together in parallel with a battery. We're going to find out how it looks when it's wired in parallel and complete a VIR chart for that, and then figure out which bulb is the brightest. Let's go. Let's go. Let's get some nice dark paper here. That'll look nice. All right, let's do this. So, and this was in a nice purple color. Let's go. All right. So, first of all, we got our battery. Just do a big loop here. And let's do resistor 3 there, R3. And then make some branches there. And do R1 on that branch and R2 on that branch. And then our battery for this one is going to be a 12-volt source, and we're going to be looking at a 4 ohm, 6 ohm, and 12 ohm resistors. Okay, so now that's how your parallel circuit's going to look. Let's do a VIR chart for that. So we're going to have V equals I times R, and then P equals I times V over here on the right. Let's separate it with a thick line and forget about it until we're all done with the VIR part. And R, 1, 2, 3, and then the battery. Wham! Get some rows for those, and get some columns over here. All right, now, first of all, everybody's in parallel, so we're going to have the same voltage drops for everyone. So we'll fill those 12 volts in, and then let's see if we can unlock some rows. So we have all of the 4 ohms for resistor 1, the 6 ohms for resistor 2, and the 12 ohms for resistor 3, and so then we can use VIR to get all of the currents, and then all of the currents will add up to get the total. And I'm coming at this from a different route than I did in the first time. The first time I used inverse addition to add up the total resistance, and then I got this, and then I unlocked the total current, and we kind of went from there. But this time I'm going to get in the individual currents and add them together to get the total current. Let's do that. So we're going to have 12 divided by 4, and that's going to give us 3 amps of current. Then 12 divided by 6 is 2 amps, and 12 divided by 12 is 1 amps, and 3 plus 2 is 5, plus 1 more is 6 amps total. And what times 6 will give us 12 volts? 2 ohms times 6 amps will give us 12 volts, and we have the VIR chart completed without having to do the inverse addition that we did before. Now all of the power values, let's do those in this nice yellow color. And so those are all the I times the V's. And so 12 times the 3's is 36 watts of power being dissipated on resistor 1. And then 12 times 2, 24 watts of power. 12 times 1, 12 watts of power. You can add up all of the amounts of power and get the total power of 72 watts. And just to double check, 12 times 6 is 72. So doubling, checking, huzzah, hooray. Now one last way to double check is to do that inverse addition for the resistance. And so let's go and do that. So let's really quickly, the total equivalent resistance is equal to 1 over R1, which is 4 ohms, plus 1 over R2, which is 6 ohms, plus 1 over R3, which is 12 ohms. And then don't forget to inverse the whole thing when you're done. And so keep on keeping on. Get that common denominator. In this case, it's going to be 12. And so 1/4 is going to be the same thing as 3/12, and 1/6 is going to be the same thing as 2/12, and 1/12 is the same thing as 1/12 to the -1 power. And let's get this answer then. So 3 plus 2 plus 1 is 6. 6 over 12 ohms. And then flip it. 12 ohms over 6. And the total resistance is 2 ohms. And that is what we had right there, using the fact that the currents add up and then using VIR to calculate the total resistance. Awesome. So there's the first one. Done. The only thing we didn't do is figure out the brightness of the bulb. So let's rank those brightnesses. So let's do that. And that is going from the powers. And so we see number 1 is R1, and number 2 is R2, and number 3 is R3. And so there we have the brightest bulbs in the box. Bam. Okay, now let's get after that second one. So going back to that one, here it is, practice number 3. We're going to have a 10 ohm, 20 ohm, 30 ohm, and a battery of 24 volts. We're going to wire them in parallel, complete a VIR chart, and find out which bulb is the brightest. 10, 20, 30, 24. Let's go after it here. Dun, 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 dun. Bam, bam, whammo. And blue, I say. So battery, whoom, whoom, whoopsie, wham, wham, huh, duh, 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 resistor, that'll be R3, huh, and that was 30 ohms. Let's get a branch for R2, huh, R2 equals 20 ohms, huh, branch for R3, huh, huh, I mean R1, R1, huh, is 10 ohms, and the battery, 24 volts. Huzzah! There it is in parallel. Let's get a VIR chart. V equals I times R. And then PIV is left over here on the right until we're all done. Wham, wham, wham. R1, R2, R3. Battery. B-A-T-T for battery because I'm out of space. Wham. Get the rows. Get the columns. Shazamba. Okay. Now, parallel has the same voltage drops for every branch. And so we have 24 volts, 24 volts, 24 volts, 24 volts. All of that freebie. Yay, that's awesome. Resistances. 10 ohms for R1, 20 ohms for R2, 30 ohms for R3. Let's get the current. So again, we can use our little strategy of doing VIR for all these. So 24 divided by 10 is 2.4 amps. And then 24 divided by 20 is 1.2 amps. And 24 divided by 30 is 0.8 amps. Hooray, hooray. You can add those together in parallel because the current split to go down each branch. And we get a total of 4.4 amps. And now you can use VIR to find that total resistance. And so we do 24 divided by 4.4 and we get 5.5 ohms. Do the power. Do the power. Do the power equals the brightness. Let's go. I times V. Boom. 24 times 2.4 is 57.6 watts of power. 24 times 1.2 is 28.8 watts of power. 24 times 0.8 is 19.2 watts of power. Add your powers together and you're gonna get 105.6 watts of power. Confirm that. 24 times 4.4 to double check. Huzzah! Brightest bulb in the box is going to be R1 brightness. R1 is going to be first. R2 is going to be second. R3 is going to be third. And we got the brightness of the bulbs based on the power. Oh yeah. Double checking that total resistance by doing the inverse addition is going to look like this. Sigma R equals big parentheses 1 over R1, 10 ohms, plus 1 over R2, 20 ohms, plus 1 over R3, 30 ohms, wham, 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 to the negative 1 power. Don't forget that sigma R equals, get a common denominator. 30 will not work, 20 will not go into 30, but 60 will do. So 6 over 60 ohms plus 3 over 60 ohms plus 2 over 60 ohms. Whammo! Negative 1 power. Adding all those together. 6 plus 3 is 9. 9 plus 2 is 11 over 60 ohms to the negative 1 power. Flip it to get rid of the negative 1 power. We get 60 over 11. And 60 over 11 is a total of 5.45, which rounds to 5.5 ohms. Dun, 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 dun. We double checked that part as well. Hooray! Verb chart completed and double checked. Thank you for physicsing with me. This was the Science Hutch. I was the Hutch. This was the amazing science. You're the amazing physicist. Happy physicsing. Boom. Knowledge.